Mark Rotsart from Rotsart Dental Lab and Emerald Dental Works. Emerald Dental Works, we started 2004 as outsourcing providers. We have grown to suppliers of materials and equipment in the dental industry. What we believe in the systems we sell, we use them every day. And we're going to do, during this COVID-19 world that we live in of isolation, we're going to be doing a bunch of Zoom interviews with specific people in the industry. The first Zoom introduction and the first one we're going to do is regarding print, and that's with EnvisionTEC Technologies. EnvisionTEC's a 3D printing company. They got a new printer out. Well, it's been out for over a year now. It's called the Envision One. It's getting great reviews, and we're pretty excited about where that's going to. Sharing the screen with me is Kevin Dillon. We've known each other for quite a while in the dental community. And Kevin, I'm just wondering if you could just briefly describe your background in the dental industry.
Thank you, Mark. I'm glad this is an ingenious way of doing, kind of featuring your companies for Technorama. It's been a while since I've missed that show, so this is a great thing you're doing. I appreciate it. You and I have gone back a long way. As a matter of fact, our families go back decades when my father and your father worked together.
Yeah.
And my father started his company in 1989 after he left Williams Gold when it was sold to Ivoclar.
Yeah.
And I've been in the industry since 1990, working alongside him with metal art, metallurgy, learning about porcelains, selling Enigma teeth. And so this dental lab business and the dental business has been kind of in my blood from the time I was in my working career. About 8 years ago, I felt it was important to get into digital dentistry, and that's when I got involved with 3D printing. I actually left the dental business for a few years and sold Stratasys printers in the industrial sector. And 5 years ago, this year, I came to EnvisionTEC, back to dentistry, and have been involved with EnvisionTEC for the last 5 years. So I'm well-versed in the dental business. I'm well-versed in the dental lab field. And over the last 8 years, I've become a subject matter expert in 3D printing. So.
Yeah, and I think the advantage that you bring to the market is your knowledge base of the dental lab industry as a whole, and not just, well, this is a 3D printer and, oh yeah, we can do these things in the dental market. So, I think that's very valuable. How did EnvisionTEC get started?
Well, Al Sablani is the CEO and founder of the company. And in the 90s, 3D printing was something that he worked with 3D Systems, Stratasys, LOM, which is Limited Object Manufacturing. And in his workings with 3D printing as a computer and electrical engineer, he wanted to improve the speed and the quality of the print jobs that existed at that time. Towards the end of the 90s, the DLP projector from Texas Instruments became popular with use in the LED TVs, the PowerPoint projectors. It was a great invention because now we didn't have to carry those carousels around all the time when we had our presentations. And he had a thought. He felt that if you were able to project the STL layer using a DLP projector into a photopolymer resin and cure each STL layer through that method, that would be a benefit in 3D printing. And that's exactly how EnvisionTEC got started. In 2002, he launched his first DLP printer. And since that time, we've created, not only created the DLP, but pioneered the DLP technology. And we entered the dental market in 2007. So people look at the 3D printing industry now and they say, wow, this is a new technology that we got to take advantage of. When in fact, we've been perfecting this technology since 2007 with our P3 printer, which you had at one time where we were printing the wax copings, and now we're printing Class 1 and Class 2 FDA cleared materials. So we've come quite a long ways.
So it's interesting. You mentioned the DLP, and you kind of stole my thunder for my next few questions. But if you can just kind of, again, you talked about the DLP and how that differs from other things on the market. Can you just kind of go into that a little bit more? And and DLP stands for what, and why is it different from, is it SLA?
SLA, FDM, there's various methods of creating a 3D printed object. DLP is digital light projection, using a projector underneath a bath of resin, projecting the STL layer up into that resin, curing each layer one at a time. And it doesn't matter whether there's one part on that build plate or there's 20 parts on that build plate. It all projects all of those images all at the same time. So it's the same speed for one model as it is for 20 models or 7 models. When you compare it to a popular and the very first 3D printed technology, which was SLA. SLA stands for stereolithography, and that uses a laser that beams into the photopolymer resin and cures one voxel at a time. So it's much like a dot matrix. It's basically filling out each voxel. Voxel is a volumetric pixel, so one pixel at a time, so to speak. And that technology, even though it's the oldest technology, is very, very slow. And if you're doing one model or 2 models a day, I guess it's okay. But when you're trying to do 6 models, it's very slow, and it could take hours upon hours. The other popular technology that started in the dental industry a while ago is the other large 3D printing company, and that's Stratasys. And they use a technology called PolyJet. And PolyJet operates much the same as a desktop printer that you have on your desk that you print out a letterhead. You've got a print head that rasters from left to right, depositing ink onto a piece of paper. Stratasys does the same thing. It has a print head that's fed through photopolymers in the bottom of the tray, and it rasters from left to right. That technology has not advanced when it comes to materials, for one, or into the type of speed or quality that we're looking for now in the dental business. But the DLP printer still has been copied by every company that has come onto the market, and that is the printing method of choice in our industry.
Okay, this is slightly off topic, but so and you saw it even in Chicago. You saw a few printers, and it was the metal printers. Do you have any knowledge or experience with metal printers that are on the market, or that type of technology? Because is that technology laser sintering or laser melting?
Yeah, it's SLS. It's selective laser sintering, and that uses a bed of alloy powder, and then the laser cures each part piece by piece. Now that is in a very advanced level of 3D printing, and you can get some excellent parts. I mean, they make titanium body parts through the use of that method.
Yeah.
The problem with that method in our industry is it's too expensive for a laboratory to get involved. I mean, your basic start for a rock bottom metal printer is $250,000. If you want to get something decent, it could be $1 million. So for outsourcing titanium parts, or you want to outsource metal 3D printed parts, it's effective that way, but it's not the type of printing that you would do in-house.
Okay, yeah. So it's more of a printer for larger volume outsourcing companies that,
like Argon.
Yeah, that can do that. Yeah. Okay, so DLPs, there are other DLPs on the market, and if you could kind of mention a few of those and what makes EnvisionTEC's DLP different from them, besides being the first users and inventors of this system.
And that's a fair question. That's a question that I get all the time. And when you look at a $2,000 DLP printer, or you look at a $20,000 DLP printer, and you're saying, well, DLP is DLP. Why don't I just use the lowest cost printer that's available if they're both are all the same? Well, they're not all the same. And it's not just the manufacturing of the printer itself, but it's the DLP chip. See, Texas Instruments doesn't make one DLP chip. They make a variety of DLP chips. And the least expensive and the most common used DLP chip is a broadcast DLP chip. That is specifically designed for determining the differences within color. Perfect for a PowerPoint presentation. I got variance colors. It brings out the brightness in that colors. But we use an industrial DLP chip. And that DLP chip is specific. We can calibrate that chip using what we call grayscale manipulation. So in a standard DLP chip that maybe $50 or $25 that you put into an inexpensive 3D printer, we're using something that's much more expensive, and it will differentiate between 200 or 255 shades of gray. Now this is important because when you're printing a model and you look at the surface of that model and you see the layer lines or the fingerprinting or the topography or however you want to discuss it, it is more prominent in a printer that uses that less expensive DLP chip than uses the DLP chip, which allows us to manipulate the grayscaling, soften those edges, and do what we call pixel tuning, where we can overlap those STL voxels to create a much more accurate product by printing it through this type of, using this method of DLP. The other thing that's key to understand is the projector is important, because you can use a very inexpensive projector and it will wear away quickly. If you use a projector that has a plastic lens, for example, that plastic lens will start to deteriorate, just like a headlight on your car does over a period of time. It gets cloudy and it becomes, you get fuzzy or misprints or inaccurate prints. So it's important that we use like a Carl Zeiss crystal lens on those. So it's those small details in accordance with the high-end DLP chip we use that differentiates our DLP printing from the rest that are on the market.
Okay. Talked about the differentiations of your product on the market, and of course everybody compares the differentiation of one printer over the other printer. You know, it's like, you know, how many microns can your printer print, and what's the accuracy? The accuracy is measured in microns, and you know what's the difference between people go, oh, I want to print 10 microns, but you say, are you truly printing 10 microns? You know, like, can you go into that clouded world of people selling, how they describe the accuracy of the printers? And
first of all, I mean, it's a very muddled world when it comes to accuracy, because many people will look at a figure that says I can print at 25 microns, but they're not exactly sure what they're measuring. And in most cases, what they're measuring is the z-axis, the vertical height. And you can manipulate that from, you know, 10 microns to 300 microns, which is the thickness of your layer. So even if you're using an inexpensive Form Lab printer, they can get their Z height down to 25 microns. However, that's not accuracy, that's resolution. Accuracy is determined on the X and Y axis. And so when you look at what we consider accurate versus what, let's say, an orthodontist or an ortho application, we meaning crown and bridge space, the orthodontic applications seem accurate are two different things. So we want to have the tightest XY accuracy as we can. Now, there becomes a point of no return where I can get my XY axis down to 10 microns if I want to, using the continuous printer. But it becomes so slow that the benefit doesn't outweigh the speed. We found that the sweet spot for a crown and bridge application to be able to print implant cases, accurate crown and bridge models, is be able to print at around 50 microns on the X and Y and 60 microns on the X and Y. And that's what we're doing with the EnvisionOne. The EnvisionOne, using this grayscaling and the pixel tuning, we're at 60 microns on the X and Y. And if you asked me straight up front, what is the biggest feature, what is the biggest advantage to the EnvisionOne? In my opinion, it's not speed, although it's very important. My opinion is its accuracy. I've taken this printer into a laboratory. They've given me a Crown and Bridge model or an implant analog case, and I've been able to print it at the 50 micron resolutions and have that analog drop right in. That's what you want, and that's what accuracy is considered in the EnvisionOne. So the DLP chip is important to that, and the continuous printing is also important to that. So looking at that XY axis is really the definition of what we want to see in accuracy, and that's where we are with the EnvisionOne.
Like with the EnvisionOne, it's, correct me if I'm wrong, it's a CDLM technology. Is that correct?
Yes.
Okay, and that is it's continuous printing process. But I'll let you, if you could go into what is continuous and what is the CDLM technology.
So let me explain a little bit further DLP so you have an understanding of what continuous is. In DLP printing, you have, let's say you have your basement.
Oh, which you just happen to have one there.
Yeah, I got a basement right here. So this particular basement is going to be filled up with materials. You're going to put your resin in here, and then your platform sits above it, okay? When you print, the platform comes into the material tray. It squeezes that material tray at 100 microns or 50 microns or whatever you're printing at.
Yeah.
The light cures it from underneath, and then those two pieces everything's stuck together. So now it has to peel away, and everything's stuck on top. Now for the next layer, it comes back down, and it peels away, and it prints like this.
Yeah.
And there's a video which shows that process.
Okay.
With continuous, one other thing. When it peels, it creates separation forces. And those separation forces can create misprints. It can create print failures. It also puts stress on the part, and it doesn't allow us to print thin parts, and it reduces our accuracy.
Okay.
If you've ever heard anybody say, don't print your models vertically because they're not as accurate, that's because that peeling process is disrupting each of those small cross layers. If I'm printing something in an angle like this, like an arch, this SCL cross section is very thin, and as I peel it, it disrupts it, and I don't have the accuracy.
Okay.
So it would be like like the van der Waals forces. If I take a piece of glass, I drop a drop of water on that glass, take a second piece of glass, and sandwich it on top. I can't pull them apart unless I break that seal. That's exactly what's happening on standard DLP printing with those separation forces. With continuous, we're running an oxygen, a flow of oxygen underneath the resin. It's actually, this is actually a piece of glass which the oxygen runs through. So the oxygen goes through these holes, it goes through this glass, and it creates a small bed of air of pure oxygen. Now, photopolymers will not cure in the presence of pure oxygen. And that layer kind of acts as, I guess the best analogy would be an air hockey table. And your hockey puck is your STL layer that's barely sitting above that air hockey table. And so when, instead of coming down and printing like this, it's continuously printing up. And it allows us to print very thin parts. It allows us to print with great accuracy and with great speed because we're not going down and peeling every single time. That's continuous printing. There's an image that I'll show the difference between our continuous printer and the clip technology or the NextDent material, which also uses an oxygen bed underneath. The difference is, if you can see in the image, they flow oxygen under a thin membrane. That membrane, it billows up It's like blowing air into a balloon. It billows up and it creates a dome. There's actually a 0.4 millimeter differential between the center of the plate and the edge of the plate. Here, because we have a glass plate, it's flat from here to here. So not only do we have continuous printing, but we've advanced it to a level where it's accurate because of this invention of this dome, this material tray here. And it also increases the speed of compared to the carbon. So I've taken an EnvisionOne printer several times into multiple laboratories. And the first time I did it, I walked into the lab and it had 6 models printing on the carbon printer. That print job was 1 hour and 50 minutes to print those 6 models. I said, give me those same STL files, and we printed it on the EnvisionOne. At the time, I didn't know how fast we were compared to them. I knew we were a little faster. When we printed those same files, it took me 42 minutes.
Wow.
And I did that. I've done that over and over again. And so not only do we have continuous printing, but we have extremely fast continuous printing with very accurate parts.
How fast the EnvisionOne printer is compared to it, you know, compared to others on the market. That's great. The other question is how big is the build plate? How many can you fit onto that? Because a lot of people, you know, they talk to people how fast it is, or you know the type of printer it is. Then all of a sudden they go, oh, the build plate's a lot smaller than I thought it was. Like, what are we working on here?
Yeah, and that's the beauty. I mean, if you look at some of the other printers in the market that are quite popular, like the Sega printer, it's got a very, very small build plate. The NextDent's got a small build plate. We're looking at 7 inches by 4 inches, which is significantly large. If you see on a couple of the images that we're showing, I stuck 14 denture bases on the printer and printed it in 1 hour and 14 minutes. That's pretty fast.
Yeah, and that's all printed vertically.
That's all printed vertically. I can stick 6 arches horizontally on the printer and print them in 25 minutes. Okay. So I'm not doing one model at a time. I'm doing a full throughput. It's actually, because of the speed and the size of the build envelope, I have more throughput than the carbon printer. I have 3 times more throughput than the NextDent printer or the Asiga. So we've got a good size, good throughput, and good speed for this printer.
Yeah, great. Okay, and with the basement, you showed the basement. A lot of times I hear from other company or from other users about how many, and you know, obviously we know with several other manufacturers also, how many basements, like how long does a basement last for, and how should you take care of that basement? Because you know, you're always placing in different materials in that basement, and what's a good standard or protocol for that?
Yeah, in this printer, the basement I just showed, it's an expensive basement because it's a patented basement. It's very difficult to make, but the only thing that's going to wear away in that basement is that film that goes on top, and we will replace that film, you know, at a fraction of the cost of the actual basement. You just turn it in and kind of recycle it, so you have a decent ROI when it's time to turn that in. We're seeing anywhere from 200 to 250 builds on that basement, and it costs somewhere around, it's $400 US to replace that basement.
Okay.
Versus some of the other competitors that have something similar that are close to 1,000 that does not have the same length of life as this particular basement.
Yeah.
So we have if you go to our webpage, there's actually a little video showing continuous printing, and it shows the film on there. It's actually a fairly thick film compared to some of the other ones, so it lasts longer.
Okay. The post-processing of the materials. After you print, it's kind of funny, like people that aren't into printing or anything, you go, okay, now we printed and here's your print, and now we're going to post-process it. And they're kind of going, oh, it doesn't just come off the printer, you know, like it's always a question.
Magic.
Yeah, so if you could kind of go in, you know, we don't need large detail, but just kind of go through that process.
Yeah, and there's actually an important point that I want to bring up with the differences in the light curing boxes as well as I talk about this. But the process, whether it's our DLP printer or whether it's anybody else's DLP printer, you've got a part that's coming off the printer that has come out of a bath of liquid resin. So your entire part is covered in liquid resin. That is not part of the curing process. So once you take that part off the platform, you put it into alcohol. We've got a wash station that you just drop it in, 99% alcohol. It will agitate it for 4 to 5 minutes. It will clean the model, take it out, air dry it, and then put it into our light box, and it will cure the model in 3 minutes.
Okay.
So it's a quick process, but it's necessary. The most important thing that I want to emphasize on this is the light curing box. When we print in EnvisionOne, we print at a 385 nanometer spectrum. That is important to cure everything. But 385 was really important when it came to clear materials. As a matter of fact, we only printed with 405 because at the time when the Vita came out, all we had were model materials, waxes, and we didn't have much in the way of clear materials. As the clear materials started to be developed in our industry, we started to notice that and I'll send you an image, we can throw this up on the screen. At 405, the wavelength is visible. It's a white light. And that white light bounces through that clear material and over-cures and under-cures depending on how that light is reflected through the clear material. And we've got really inaccurate parts out of that clear material. So 385 is important to cure your clear parts. The intensity of the light is important too, because one of the things that I ran into, and I was frustrated with a customer of mine that was curing with a less than standard curing box, and I said just put it in there and just cure it longer and let's see how it goes. Constant inaccurate models, nothing fit. When we provided them with our PCA curing box, all those problems went away. So if you don't get that final part to the optimal curing stage, your fits won't be there. So don't think that you can take a nail curing light that you do your nails with and cure your model on and expect to have accurate parts, because it's not going to work. So it's an important stage, and I think having the right light curing box is very important for your final accurate parts.
Does the EnvisionTEC light curing box work with other systems, or is it specifically for EnvisionTEC?
No, it works with other systems. It cures at 385 and 405, and it does it very quickly. If you look at some of the competitors, like the most popular printer out there right now has a curing box that takes a half hour to cure a model. And when you're trying to get throughput out and you're trying to get models and parts out and you're waiting a half hour for the next batch to come through, my print job is done by the time that curing box is still curing. So you need something faster and something that's going to cure it so that you don't run into accuracy problems.
Okay, great. All these great features. You mentioned the dentures on the EnvisionOne, but what other applications do you have for the EnvisionOne at this time?
Well, we're growing those applications all the time. So we've got obviously 5 different model materials now. We've got 2 inexpensive model materials, actually 3 less expensive model materials for ortho applications, study models, antagonist or opposing. And then we've got a high quality model material for your crown and bridge models, your implant cases, surgical guides, night guards. As a matter of fact, we've just signed on with Keystone, so we'll be offering the Keystone soft night guard material, which is big because that's a great product.
It is a fabulous product, and that's with us. We find that that's the first question when people are asking about the EnvisionOne.
Yeah, yeah. It's so we go out and find the best materials on the market, and we've certified them for our machine. It's important to understand that we look at 29 parameters on each material to have optimal printing output. Most of other companies may look at 5 or 6 or 7 different parameters to print. So when we look at something like the Keystone splint material, we're going to run it and we're going to make sure that all the parameters that we set for our machine, we've got optimal output parts coming off that. So we're very diligent about making sure that what you're going to put into that machine, you're going to get a successful product coming out. The other things that we're looking at, and we've been talking about for a while, people may have heard, is the ability to print clear aligners without a model. We're working on that now. We're going through clinicals right now on that. So I expect going through the FDA and Health Canada, I think we'll probably introduce it sometime next year, but to be able to print a clear aligner without a model is the holy grail of printing in dentistry right now. We recently have come out with a new denture material. The talk of the town when it comes to dentures is the Densify Lucitone material in the carbon printer. I suspect they'll probably open it up down the road. But EnvisionTEC, being a materials company as well as a 3D printing company, has developed a very high-strength denture material that has significant tensile strength and flexural strength and Vickers hardness over the current Lucitone 199. So we've got a high-strength solution for both the base and the teeth, and coming out with, I think seven or 8 different colors with this high-strength tooth material, which is significantly stronger. The current material we're using now is 107 megapascals on the tooth. The new one is 158 megapascals, so it's quite strong.
Wow. That's going to change the perspective of the printed denture considerably then. Okay, so let's see. We talked about all the new materials, talked about DLP, everything else. The Envision One is your guys' main focus right now. You have other printers on the market. What other printers for the dental community do you feel that is also worth a look from EnvisionTEC?
Well, I'm not sure I should say this, but I know we're coming out with a non-continuous, less expensive printer than the Envision One. So we'll have something in the economic range. And we also have our high-end 4K P3 or P4 projector printer, which is a little bit on the price, a little high up on the price range.
Yeah.
So we're constantly coming out with different solutions. But the Envision One, it was introduced last year. It's several generations for the continuous printer. We've had a couple in the Vita range, which I think you own as well.
Yeah, absolutely.
The prices of those were much higher. So we were able to re-engineer the Envision One to get down at a decent price range for the speed and accuracy that it has. It's still the best one in the market by far.
Yeah, perfect. Okay, Kevin, I'd like to thank you for this. It's fabulous, a lot of good information there. So once again, thank you for this, and it was a great interview.
Thank you, Mark. I appreciate everything you've done for the industry. You're great. I appreciate it.
Okay, thanks. Bye.
Thanks. Yeah.
Hopefully this is of some use to you at this crazy time, and yeah, please get back to me if you have any further questions or comments on these videos. Okay, take care. Bye.